And we're getting ready to take a look at systems of inequalities right now rather than just the systems of equations. Systems of equations that we solved by graphing, you graphed the two lines and saw where they intersected. We're not necessarily interested now in where they intersect, but we're interested in where the graphs overlap. So we have that. Thank you so much. I very much appreciate that gift from the maintenance department. Thank you very much. Okay, so the graph where they overlap. So this is a live recording, everybody out there, so this is just how we do this. What we need to do is we need to graph these individually. You know how to graph inequalities. We graph them individually, and then the real answer is where they overlap. So you need to be prepared to maybe draw in some lines and be prepared to erase the ones that don't apply. So definitely do this in pencil so you can erase the parts that don't apply. But we want to start off just by graphing the first one. Okay, so this bounces back to last chapter where we graphed the inequalities. So x is greater than 2x minus 3. What would be our process for that? Okay, so we're graphing the dividing line first, right? So you're going to make your graph. And I'm being told that it's going to be a dashed line. Dashed line for this first one because it's just greater than, not greater than or equal to. So as you get ready to do that, we see it's in mx plus b form, so we can start at our y-intercept of -3. And then we can take our slope, and our slope is, what's our slope? 2. So it's 2 over 1 for this. Right, here's our 2. So 2 over 1, which means to go up 2 over 1, just to review that. So we're putting these points in, up 2 over 1. And you can do that as many as you feel like doing. It just makes it easier to draw a straight line. And then we need to do a dashed line for that one. Now you're going to just take your pencil and do a dashed line because it just says greater than. We have a couple different ways of telling which side of the line that gets to be shaded in for that. One of them is by picking a test point, but also when you have the y solved for and you have greater than, does that mean above or below? I heard somebody say above or to the well, it's not to the right actually, it's above, which would be this side. But if we needed to do a test point, you could plug in 0, 0 into that. So 0 greater than 2 times 0 minus 3. Remember, we're testing the point 0, 0. And so 0 is greater than -3. That's true. So here's 0, 0. So we're hitting this side. I've got some lines here, but do be prepared to erase some of them because we're looking for the place where it's going to overlap. So maybe just put a few lines or some ghost lines that you can get rid of the ones that don't apply, because we've got two inequalities to deal with here. So you've got your first half done, okay? And then you need to deal with your second half. And the second half, oops, that's too fast. The second half, y equals -1/3 x plus 4. Is that going to be a solid or a dashed line? Solid, because of the or equal to. And we start where for this graph? +4, so 1, 2, 3, 4. That's hard to see from across the room. 1, 2, 3, 4. And then our slope of -1/3 tells us go which way? Down 1, right 3. So down 1, right 3, down 1, right 3, on and on and on. And you want to think of this one kind of separately after we get it graphed. So I want to get my line back. All right. All right, somebody's light bulb just went on. That's good. So we have this one like here. So what you're then thinking about is for this one's less than or equal to, so which way is that? Below, good. And I'm seeing some hand signals there, so that's good also. So down below. Okay. If you're doing it in pencil, you would, really what you would do is you wouldn't even draw this one. You're trying to get the overlap. So like you found out that it's below. So you would ignore this part that's below that wasn't shaded in here, and you would just kind of add in the shading here. Color this in really strongly, because this is the part that would make both of them true, and then erase this extra piece up at the top. So the way that looks, all right, we have, here's this, but then you're erasing the part that is not in both, because this actual solution is just this part here that's in green. So you would be doing some erasing in that so that your final answer looks like this, nice and clean. And this is the region where all of the correct answers are. And if you wanted to go ahead and test to see if you were right, you can pick any point in this region and make sure it makes both of them true. So our 0, 0 point is in this region. It's divided up into 4 places, and only one of them is going to be where it makes both of them true. So 0, 0 actually makes both of them true. So it is this region. That's another way that you could check to see which of the 4 places actually is where the solution lives. Okay. And sometimes you don't physically draw in both of them. You can like take a ruler or something like that, and here I can show you, like in your thought processes, if you were to take like a line along here and you're thinking, okay, in my mind I'm thinking that this way is greater than, and I'm thinking, in my mind I'm thinking for the other one, this way is less than. So I'm thinking about where both of those things would have overlapped. So we've got those. Okay. So once again, it's the place where they both overlap each other. Now in the next one, you have a little bit of solving for y to do first. So that's a thing. If you don't have it solved for y, you have to do that. And we can't forget about our friends, the absolute values either. Although some of you might want to, those things are not going away all year. The idea of moving a graph is not going away. We're going to apply that to other things. So please make sure that if you don't quite get that yet, make sure that you get some help. Come after school, get some help, talk to a friend, Skype, whatever, FaceTime, whatever it is that you do that you can get some help, do that. Okay? All right, so let's take a look at this. We need to solve this one for y. So how do we do that? So half x plus 3, because once you do this, we have 2y. It's not working here. Let me do this up here. There we go. So we have 2y minus x equals 6. We're just looking for the dividing line first. So you take the negative x and add it to both sides for those that need to see that. And that's where, when it was just said a minute ago, y equals 1/2 x plus 6 comes from. And then you graph that one by not plus 6. It's not plus 6, it's plus what? Plus 3. Okay, and this is going to be a 3. It is going to be still less than or equal to. And we didn't divide by a negative, so we're okay. We'll still be less than or equal to, so it's good. If we're thinking about the dividing line, though, you don't have to do that. And so when we graph this and we take a look at the 3, which way do we go then from there? Because it was, sorry, it doesn't stay up. Y equal up 1 across 2. So you would go through and you would do that. And then it's y is less than, so once you get that line, which way are you shading? Below. Okay, so you would go that. You're going to make a nice graph, and it'll be below. I didn't want that much. I went too far. Here we go. That's what I want. So below. You could plug in 0, 0 back in the initial one to find the test point if you want to be absolutely sure. So 0 and 0 here would give you 0 is less than 6, which is true, which also brings it down and below. Then we have this one, our absolute value. And do you remember from the last chapter how the absolute values work? Where's the vertex for this one? -2, -1. Good. This one takes it that way. So -2, -1. Forget that. That's not working. So -2, -1. And then, so right down here. And then you're going right straight up through the corners. So it would look like this. Okay, there's nothing changing it here. There's no stretch. There's no compression. So just up 1 over 1. And so we have this part of this graph. And then greater than or equal to for this part would send it which way from the absolute value? Above or below? Inside or above, right? If we did our 0, 0 test just to see, 0 greater than 2 minus 1, but 0 greater than 1 is false, so it would have to be where 0, 0 is not, so that sends it up above. But when you go up above, the part that's in both is this little blue section right here. So the final answer is just that little blue section. So you do just very, very light shading when you're doing the sub-steps so that you can finally end up with just the part that overlaps and makes both of them true, and that's your actual answer. So right, oh, this one should be down further. -2, -1, right down there. And then it's the part that would be in the little triangle. Okay. Alrighty. All right. And then we have another one, I believe. Okay. Which one? The straight line? It starts at 3. 1, 2, 3. At the y-intercept and then up 1 over 2. So that's where this one came from. And this one is below. This one, the vertex is at -2, -1. And it is an absolute value function, so it looks like this from our previous work. And above, so it's just this little shaded region right here. Okay. All right, just one more for today. And then we'll take questions on that homework. This one, though, has 3. So since this one has 3, it just means that you have a little bit more work to do and then a little bit more erasing at the end. And yes, I know that the thing is kind of over here, and yes, you see, but let's think this through a little bit. First one, absolute value. And we have a +3 in here. So where's our vertex going to be? -3, good. -3, 0. What's this negative do for it? Good. It makes it flip upside down. So you still have your absolute value function, but it's an upside down absolute value function. And once that gets drawn in, we could do a test point, or you can use this idea of less. The idea of less tells you it's going to be shaded which way? Down. Okay, so below it. It's like this. Dashed lines, because it doesn't say or equal to. So we're going to do this 3 times. 3 times for this one, because we have 3 graphs. And so you'll be eliminating more and more and more things as you go, so that you're getting just the pieces that are relevant. This one needs to be solved for y. And it becomes y is greater than what? X minus 2. So be careful when you graph this. Put it on x is, the y-axis is -2. And then up 1 over 1. So it kind of has this interesting thing, is it's coming out to be kind of parallel to one of the sides there. Oh wait, what mistake did I just make? It should be, yeah, good. It should be dashed line, so we'll change it to dashed line. So we've got the dashed line going down through there very carefully. And then which way, above or below it? Above it, so that's going to eliminate this stuff down here. So we have this, we're going up above, it eliminates the stuff here. Eliminates this stuff down here. Eliminated too much all at once. Because we're just looking at the above part, so we can even just do this by getting rid of it. Because the above part, so we've got below this one, above this one, and we have one more. Where's the y equals 1? Is it vertical or horizontal? Horizontal. So at y equals -5, you have a horizontal line. 1, 2, 3, 4, 5. Got a horizontal line, again dashed. And this tells me it's the ones above it, because that's where things are bigger than -5. And so then it goes ahead and it gets rid of this stuff that's down here below it. So it's all the things, it's where it overlaps. You can draw them all in and erase if you want, or you can erase as you go, so that you end up with just the answer right there. So this is the region that is shaded in by all 3 of those different things. So it does review your graphing of the equations, because you've got to get those border lines, and then also then the place where it -5 for this one, because y is greater than -5, so -5 is where our horizontal line goes. 2, 3, 4, 5. Okay, so that is great. And I think we are done. And here